Right. Okay. What we have learned in the previous lecture is the basic principle of the pump. So if you look at the pump, the basic principle is very simple, right? It's just using the extended Bernoulli equation. You calculate the HS. When you get the HS, you equate with HP. Then you get your Q. So the main problem is getting the correct Q, right? It can be twisted, right? It can be twisted rather than asking you about the Q. It can be twisted asking you about the power, because the water horsepower is Q times delta H times gamma. Gamma is constant and delta H is function of Q, right? Once you get your Q, you can calculate HS, right? HS or HP, because Q is at HS equal to HP. So when you calculate HS and HP, it has to give you the same value. I told you, if your HS and HP is not the same, mean during the calculation you make a mistake. Either your calculator is not cooperating well with you, or your finger got some problem. Right? Your eyes, your brain think you want to press 9, but your calculator, when you press the calculator, you got 6. Common. So the easiest way to check is comparing HS and HP. When you get your HS and HP, you can calculate your W water or water horsepower. When you get water horsepower divided by the efficiency of the pump, you get your sub input. Okay? And then evaluate pump performance and characteristic. That one we have done. Actually, the characteristic, the pump performance is given as an equation most of the time, because in the exam you don't have time to draw the table. Okay? You can complain to me that the time is not enough if I give you the graph. If I give you the pump characteristic in a graph type, then yes, you will have to draw one by one and then get it. It will take time. Or if I give you the table, right? You have the table, it will take time also. But if it is equation, you just equate HS equal to H. Okay? Select the most suitable pump for specific application. This one using the NSP. Pump specific speed or number. That one you have 3 different NSP. One without unit, the internationally accepted one. Another one is the European customary unit, and the other one is US customary. Okay, and the graph got all those 3, so you just get the value and look at the graph. Which one is the most suitable one, right? From that, actually, you can also get the efficiency of the pump. Any question about the pump? No? Okay? If not, then another turbo machinery that we will look into is the turbine. Actually, you have a lot of turbine. We have hydro turbine, we have a wind turbine, and we have another one is gas turbine. Of course, out of those 3, gas turbine is the most challenging, the most difficult one to solve, because it is dealing with compressible flow. But it will not make your life miserable, so we will just consider the hydro turbine. Right? It's just enough for you. Okay, but don't limit yourself, just study hydro turbine, because in the fluid mechanics actually you can look into the wind turbine and the gas turbine. Okay, this is turbine, this is Pelton turbine, and this one is the reaction turbine. Both of these you have looked during the experiment, right? Yes. This one is the Pelton turbine. The only difference with the one we have there, the one we have in the lab having one nozzle, right? But in this case, it has few nozzles. The reason is to make the vibration minimum. Because if you have one side hit by the water, and you know the water is not as smooth as you think, right? The jet is kind of vibrating. So if you do that, you get a lot of vibration problem. That's why sometimes you get two like that. Okay? The other thing is, if in the pump, the blade is called impeller. Right? The blade is called impeller. In the ship, the blade is called propeller. In the turbine, the blade is called the runner. The one that is rotating, moving. Okay, this is the runner. Okay, and the turbine, in contrast to the pump is energy supplying devices. It provides energy to the fluid to move. While for the turbine, it's extract the energy from the fluid and take it to make a rotational energy, rotational movement. If you want to split it, you have wind turbine, gas turbine, steam turbine, and hydro turbine. Right? What's the difference between this and this? This one using the gas directly. You know, you burn LPG, and the hot gas you used to drive the turbine directly. This one usually, if you have an aircraft or airplane, you see that thing, the one that is installed is gas turbine. The one installed in the aircraft, the jet engine that you think is just jet engine, is this gas turbine. So the turbine is driven by a hot gas, exhaust gas. Whereas the steam turbine, the hot gas is used to heat up the water until you get superheated steam, and then the superheated steam will be used to drive the turbine. Sometimes the gas turbine, right? The gas turbine is used first. So hot gas is used to drive the gas turbine. The exhaust of the gas turbine is used to heat up the boiler, create the steam. Then the steam will be used to drive this. Okay? Not enough, the exhaust of that thing can be used to do the chilling water, like our GDC. So using absorption chiller, you can have 1, 2, and the next system. So usually gas turbine is used as the first one, then you have the steam turbine in the second, and then you have the absorption chiller after that. That's why nowadays the system is very, very efficient, because it uses the exhaust gas. Wind turbine, okay, there is 2 wind turbine. One is the horizontal axis and the other one is the vertical axis. Okay. No wind farm yet in Malaysia. Maybe next you will be the one who invests on the wind turbine. At the moment, the most advanced, not most advanced, the front runner is China. They build a lot of wind turbine, wind farm in the mainland. Okay, they are good in this and that. Okay, good at that, this as well as this one. Okay, so hydro turbine utilize large elevation changes. So most of the time when we are dealing with hydro turbine, you have elevated reservoir and lower reservoir, and then you drive the water from here to there, right? Any one of you has gone to TNB grid?
Luffy.
Huh?
Luffy.
Luffy.
No.
Okay, if you take, if you are smaller class, actually we can preview them, but we have other possibility. In TNB grid, you will see the hydro power plant like this. Okay. So there are two basic turbine. One is impulse and the other one is reaction. Right? One is impulse and the other one is reaction. And we consider both of it in our experiment. The impulse turbine is the Pelton, the one that we have. And reaction turbine is Francis. Francis. Okay? Impulse turbine is good at high elevation if you have high head but low flow rate. Reaction turbine is good for the low head but high flow rate. The best, of course, if you have a high head and high flow rate, like over there, 110 meters, and the flow rate is huge. Right? So, if you are living in Cameron Highland, you see a lot of those what they call it here, waterfall. If the waterfall has a smaller flow rate, you can install a Pelton turbine and then you can have your own electricity. Of course, maybe someone will not be happy because then the waterfall will not be there anymore, right? Because you close it, you put a pipe, right? So no more waterfall. So sometime building a power plant can be an issue. Don't think it is because it is kind of environmentally friendly, no emission, then it will be easily built. So sometimes because you want the waterfall, but if you have this thing, no waterfall anymore because you close it, right? And you drag the water through the penstock.